Living things such as coral reefs and trees can also provide us with information about Earth's climate in the past. So coral reefs, while beautiful to look at, they also help us to learn more about past temperatures, nutrient availability, salinity, or how salty the water is, and other information. Similarly, trees can help us to learn about past temperature changes and moisture levels in their surroundings. And we think of trees as providing information only going back maybe 50 or 100 years, but there are some species of trees that are very old trees. And so an example is the Methuselah walk tree, which lives in the White Mountains of California. And these are known as being some of the oldest trees in the world. These are twisted bristlecone pines, and they grow very, very slowly, and they've preserved a history of climate in their growth rings. So if we use some of the dead wood from these trees and living trees, they can take us back about 9,000 years to show us what the climate was like leading up to the last ice age. So tree rings, like I said, they can be used to look at precipitation levels or temperature. With each year of growth, a tree will add another ring of thickness to its trunk. So you can see here on this picture, there are different rings in the trunk, and each ring represents a year of growth. In dry areas, such as California and Arizona and other deserts, precipitation is going to be the main factor that controls growth of the tree and how thick the rings are, so how much um, tissue was added to the ring of the trunk in that year. In places where there's lots of water, so places like the Pacific Northwest in the United States, which is a rainforest, temperature may be a more critical factor in determining the thickness of those rings. These rings are also useful because if there are scars in the rings, then you can tell when there were forest fires. So you can see on this chart, the line going through the data shows the average growth and the average precipitation over many, many years using the data from those bristlecone trees that we saw in the last slide, and you can see how much it fluctuates, and that's by looking at the thickness of those tree rings we can see how much precipitation there was over different years. Coral reefs tell us similar types of information, so you can core down into the coral, pull out a core, and then you can look at the rings in the coral. Coral also adds a layer with each year or with each season that it grows, and so you get these growth bands in the coral that show a year of growth, or I'm sorry, I shouldn't say year, it should be season of growth, so it might be different than it might not be the same as a year. Coral shell thickness, the thickness of these bands, is sensitive to different aquatic parameters such as temperature of the water, water clarity, rainfall. So rainfall can wash different sediments and nutrients into the water, and also general nutrient availability in the water. So just like with trees, coral doesn't live forever and there are limitations. They only live up to a few hundred years, and they only live in tropical water. So they can only tell us what conditions were like in tropical areas up to a few hundred years ago. But they're still useful to kind of provide another level of evidence for climate change.